A very good morning. Can you all see the screen?
Yes, sir.
Yes, sir.
Yeah. So the next topic, the first module, what we going to discuss today is ensemble learning algorithm. So far we have discussed various learning problems. Again, various machine learning perspectives, then issues, then what is a concept learning, then what do you mean by version spaces and candidate elimination algorithm. Before that, finders algorithm, inductive bias, and decision tree learning, how to represent the decision tree, then the algorithm we'll see in the lab side. Then today we'll discuss ensemble learning algorithm. So only one more topic left over, the random forest. Random forest is one of the technique under ensemble algorithm, right? One is a boosting or bagging. Another one is a random forest. These two are the techniques under ensemble algorithm. So we'll see what do you mean by random forest in the next class. But today's class we will discuss what do you mean by ensemble, what is ensemble learning, what are the different types of ensemble and different techniques of ensemble along with some few examples. Okay, so with that we will wind up the module 1. So again, so this itself will taken almost 2 weeks, 2.5 weeks. My next module is little bigger, so maximum we'll try to cover the concepts. We cannot cover the whole module for fat cat 1. So whatever we complete, so we will keep that for as an exam syllabus. When is your cat 1?
February 28 to March 7 or something like that.
28th. So okay, we have 2 more weeks. 3 weeks we'll wind it up. Okay. So we will concentrate only important topics in the second module for exam. So that we can ask questions. Linear regression, logistic regression, we'll cover that first. Then KNN we can keep it at the end. So linear and linear regression, logistic regression, and one optimization technique, a gradient descent we will see. Then with that we will have wind up module 2. Okay. So today we'll see what do you mean by ensemble. What is a ensemble learning? So any idea? So what do you mean by ensemble? Ensemble learning. So in ensemble learning, so I'll just will go ahead with the example or scenario. Just here written, I like you assume you're a movie director, right, or assistant director. You have created a short movie. Just you have taken a shot in short films, right? So assume you're just a movie director or whatever it may be, a creator or designer or whatever something. Idea is yours. You're creating a short movie, but before releasing that movie on public to the public, you need to collect the feedback, preliminary feedback or ratings on the movie. So what we will do, what are the various possible ways by which you can do that? So simply, so what we will do generally, once a movie is ready, the movie director or the producer, he will call, they'll release the movie in some theaters. The respective random peoples and the core team, along with some random people, they'll watch the movie. Then they'll get the feedback. That is the first stage of feedback, right? So then if we have any editings, all other things are pending, then they'll go back and they'll do all such things. So ensemble learning is also similar to that. It is a kind of group of items, right? So it says some group of items as a whole. So we are not seeing rather than the individuals. We never see as items are individual. We will see as a group of items. That is what ensemble learning. So you can see, you can get the results as a whole. So but you should not see, you should not collect the response or predictions from the individuals. So that is what ensemble learning is all about. Now assume this scenario, you're just the same scenario, you're taken a short film before you're publishing into the YouTube or OTT platforms or somewhere. You need to collect the feedback. How will you do it? What are the possible ways? Can you post it? Can you post it down in the chat box, or you can let me know what you will do and say me which option will be the perfect preliminary feedback. Generally, I will ask, just generally wherever you go, whatever you would like to buy, you will ask your friend, you will ask your mom, you will ask your parent, you will ask your friends, right? So so can we go with this? Can I buy, or can we buy something like that? So then before that, what you would have done? So what is the feedback? How will you collect the feedback of the particular product? That is was my question. What are the possible ways which you can do this?
From the reviews in the Amazon, or I mean the
No,
platform in which from we are buying.
no, you're not releasing. Before releasing, see, you have collected on short film, you have taken on short film. You have video in your hand, editing, everything is over. It is ready for live, ready for launch. What you will do? But you want to know, you want to collect the honest feedback. So what you will do? Will you call your parents and mothers? If you call them, they are close to your heart. They never give feedback. Even though the movie is horrible, they want to motivate you. They want to encourage you. They will give yes, very good only. But you need a perfect feedback so that you can move forward. So then the question here is how we will collect the proper honest feedback system. How do you predict? Here I am relating everything to the machine learning. So here, how do you predict? That is what my question. So you generally, in general, you tell me what you will do. First question is, you may ask one of your friend to rate the movie for you. Yes or no? So if you
Yes, sir.
ask, yeah, if you ask your friend what this is just a human empathy, right? So if suppose if you ask your friend what he will do, he will just your close friend. When you ask someone, obviously he might have close to your heart. What they will say, even though the movie is horrible, they never say it is like a bad, right? So if you ask them to rate a movie, they will give 1 star or 2 star online, but directly straight away they won't tell, right? So that is the first question. So this response may not be suitable. You cannot ask your closed circle. So what we will do? Second case. Okay, then another way could be by asking 5 colleagues of yours to rate the movie. This provides better idea rather than the previous one. Instead of asking one people, I am asking group of people. Now we are reaching near to the solution. Yes, I am asking group of people, but what type of group? Who are they? Who are those target audience? They are also close to my heart. They are also my close friends. They never give honest ratings. But here also still problem exists. 5 people. Why that 5 people? That 5 people may not be a subject experts on the topic of your movie. So if you would have called the experts of different movie directors from of different movies, if you call them, if you invite them as a guest, and if you ask them to watch movie, you're a movie director. If you call all other 5 movie directors to your team, then they will give 5 different views. They will give honest ideas because they are subject experts, subject matter experts. But in this case, question B is also not possible because you called your colleagues, so they may not give you proper honest ratings. Sure, because when you call your subject matter experts, they might understand the cinematography, the shots and the audio, everything. But at the same time, may not be the best judges of dark humor, right? So that is also not possible here. Then whom should we call? How about asking random 50 people to rate the movie? The 50 people no way are related with each other. So some random people. Then that would be the best choice. This would be the more generalized and diversified answers. Right? Some of which can be your friends, some of them can be your colleagues, some of them even be a total strangers. You don't know who are they. If you call all these groups together, then you will get a proper response. You will get a proper prediction, right? Proper prediction. Since now you have people with a different set of skills. When you collect group of people, when you call group of people, obviously you have different set of skills. You're mapping different set of skills or models to one scenario, one model. You're applying diversified skills to a single model, and you're predicting that is what your the best response is going to be. So this turns out as a best approach to get the honest rating rather than the previous cases what we saw. I hope you understand what I'm trying to say. So obviously always go with diversified skills, diversified models. Don't collect the response from the individuals. Collect response from the group rather than the individual. That is what the ensemble learning is all about. You need to train your model with diversified inputs, diversified testing data, your diversified training data. You should not take a single test case and you should not test it, right? So you should have a different, like that's how your hacker rank and everything works, right? It will go with different test cases, positive test case, negative in positive, different alphanumeric test case, character test case, in integer test case, floating test case. It will go with all the combinations. So you should try with that. Second one, second example. If you are planning to buy an AC, would you enter the showroom and buy the air conditioner that the salesperson shows you? I am entering into Vijayawada, just your Reliance Mall or Metro or any other Reliance retail store. When I enter, there are two people will be there in the front entrance. They'll keep all your costly items, your trolleys, your chairs, all other items in the front. They will ask you, they'll show you. The salesperson, they'll show you, sir, this is you have offer. Can you buy? Can you take it? Something like that. Will you say yes or will you say no? Our front mindset is obviously you also come across the scenario whenever you enter into any mall, people will show you many things, but we will say immediately no, because you want to have a survey, you want to visit the entire store once. At the end you need to take a decision, so decision by yourself. So because that is a human mentality, obviously, without seeing how can I buy by showing someone's idea, how can you accept my someone's idea, because he is saying the product, he is saying the price and everything, but you may not accept it because your mind has to train, your mind has to accept, your mind has to need a survey, do a survey. That is what this ensemble learning are all about. In this day and age, you are likely to ask your friends, family, colleagues for an opinion. Do a research on various portals about the model. Visit few review sites before making a purchase decision. In a nutshell, you would not come to a conclusion directly. This is what it is a common empathy, right? Common mindset. So without first simple logic, I want to buy one iPhone. So what I will do? I will do comparison. First, I will ask my friends which is the best model, macha. Then what is the best mobile within the 40,000, 60,000, right? So you may ask your friend like that. Then what you will do after collecting the opinion, you may have 2 to 3 phones in your mind. Then what you will do? You will do the comparison with the various GMS, GSM Arena or some other comparison sites, right? So iPhone 6, 7, 8, which is the best. After comparison, you will have some an idea. Then you will see, then once you select the single item, then you will collect the feedback of that item. What is the advantages of Realme phone or iPhone or other Oppo phone, something. Then you have a decision. You had a decision. Now with that, you are collecting positives and negatives. So this is how the training samples, positive example, negative examples. Then once you have decided, then only we will step into the purchase section, right? So this is what the ensemble learning is all about. Always you're collecting the response from the group of people. Always your prediction depends on the group of people, group of models, group of individuals, right? So this is what the ensemble learning is all about. In this scenario, would try to make a more informed decision after considering diverse opinions and reviews. In this case, ensemble learning, the same principle applies, right? Same logic. So we will when you submit, when you give the input to the model, it will train with the different. It will apply for a different models and get the predictions. That is what this ensemble is all about. With these example, you can infer that diverse group of people are likely to make better decisions as compared to individuals. This is what our single line definition is all about. Diversification in machine learning is achieved by a technique called ensemble learning. So diversification is very, very important. We are applying diverse set of models in comparison to single model. Instead of creating my own ML model, so I can take n number of models, I can submit. Then which is the best choice? This is what diversification, right? So I want to get the best results. What I will do, I will use first algorithm, second algorithm, third algorithm, fourth algorithm. Which algorithm gives my better accuracy, then I'll go with that. So that is what your diversification in machine learning. So then what that is what a simple example. I hope you understand what is ensemble learning is all about, right? Diversification in machine learning is your ensemble, right? So ensemble meaning, so obtained from this insights obtained from the multiple learning models to facilitate accuracy, and the improved decisions, right? So these methods follow the same principles as the example of buying ACs, right? So in learning model, noise and variance and biases are the major sources of error. So in this ensemble model, machine learning helps to minimize these errors causing factor, thereby ensuring the accuracy and stability. This model mainly is used to improve the accuracy. In the older models, why the accuracy are getting reduced? Main reason for those reduction is noise, your variance, and the bias. Meaning these are all kind of errors, right? So then such errors will be reduced in this when you use this ensemble learning algorithms. Just one more example also I just quoted, app for the travel industry. So read the story and tell me what is your opinion on this. Assume that you are developing an app for travel industry. Just assume you have Kallada Travels here. I want to Kallada is just there are different Kalladas, right? So Kallada is for your what do you call uh, uh, public transport. Also, Kallada is also for tours and travels. So, for example, Kallada is running for tours. So then I need an app for tourism, right? So then like Parvin Travels, like your what do you call uh, Orange Travels, etc. Right? So assume that you are developing an app for travel industry. So it is obvious that before making the app public, you want to get a crucial feedback on the bugs and potential loopholes that are affecting the UI experience, UI and UX. So how will you collect the feedback about your app? Because you might have developed many apps, right? Android apps or iOS apps. So how will you collect the feedback about the app user experience? Compare the first example and let me know what are the can you come up with the questions? How will you collect the available feedbacks? Any idea?
Starting and also which path is taken to reach the destination, and which route is safe, which route is easy, which route is hard, which route is long the traffic.
Okay, that is what you need to test. How will you test? Who are your target users? Generally, maybe you're new user, you're novice user, you may not know. Suppose you're a well versed developer, Android developer, you might have released almost 10 to 15 apps. You're developing next app. So how will you do? How will you check? Assume you have forum. Is that the answer? First possible option, soliciting opinions from your parents, spouse, and close friends. Asking your co-workers who travels regularly and then evaluating their response. The third one generally everyone will do. We will release my app as beta version to gather the feedback from the non-biased audience and the travel community. Is it or not? These three are the perfect feedback collection system. First, we may ask our own team, then we will go with our colleagues. Then third one, we will release the beta version. Then general public will give the feedback. Even for everything, even including from WhatsApp, everything, the beta version is available, right? Testing version, right? So this is how we are collecting the feedback from the group of people, wide range of people, wide range of peoples, right? So we are collecting the different views and ideas from the wide range of people in order to fix the issue. So this is how where your neural network and ensemble algorithms works. So it will use the same logic here. So in order to solve the issue. Fourth example. First one is your what do you call your movie. The second one is your AC. The third one is your travel app. The fourth one is mini donut factory. Assume just I want to create. There are the imagine the just imagine a story. A group of people blindfolded. Okay, so just they close their eyes and just simply they are blindfolded. They are playing a touch and tell game. Okay, we will show some item like nowadays you might have seen in some many shows. They'll show you an item, either a product. You need to touch and tell what is that. So now this game playing by some set of people. Now touch and tell game where they are asked to touch and explore mini donut factory that no one of them have ever seen before. So no one might have seen this machine before. So since they are blindfolded, the version of what mini donut factory looks like will vary. Depends on the parts of the appliance they touch. This scenario is set of students are divided into groups. So each group has five people. Okay. So one for first team they may come. So they need to touch somewhere in that factory. So suppose he is touching in this button here. In the same team, another person is coming. He is touching in the top. He is touching here. The fourth one he is touching here. With the last guy he is touching at the bottom. Then now what they need to do, this group of people together, they need to say, they need to discuss themselves in order to combine their ideas. So then he will say, I touched some tab. So then this product has some tab. This has the button. This has some moving trolley by icons. So by collecting their combined experience, then they need to finally say, the team needs to say what is this product, right? So now here in this scenario, so the team effort will give you will tell you the what type of product it is. It will give the idea will help you to identify this product, right? So that is what your ensemble learning algorithm is. So finally, based on the five, then one people may say that this is like a machine, like a bada machine or baji machine, something. With that, we can say. And then finally, you need to predict this is mini donut, right? Factory. So this response, the collective response, which will allow you to do the prediction. So that is what here group effort, the group ideas always will help you to identify or help you to predict the product. So that is what your ensemble learning is all about, right? So similarly, ensemble methods in machine learning employ a set of models and take advantages of the blended output, which compared to the solitary model will most superior option when it comes to the prediction accuracy. The main purpose is here we will go with the high accuracy models. So the next one, this is what ensemble learning is. Next one is basic ensemble technique. What are the basic techniques? There are three techniques in ensemble learning. One is max voting. The second one is averaging. The third one is weighted average. What do you mean by max voting? Max voting is logic is very simple. We will collect majority wins. That is what your max voting. So this is usually generally used for classification problems, right? So these techniques or multiple models are used to make the prediction for each data point. For every point, we'll have different machine learning models. So with that, we will make the prediction, right? These predictions by each model are considered as the vote. The prediction which we get from the majority of the models are used as the final prediction. Now you can see there are 5 colleagues of your movie. They asked you to rate the movie. So their ratings are given below. Colleague 1, they given rating 5. The colleague 2, they given rating 4. Again, colleague 3, they given rating 5, 4, 4, 4. So totally 5 colleagues they given a rating. So there are 2 5s and 3 4s. So what is a majority voting? So there the three 4s are the majority. So final rating is going to be a 4. This is what a max vote. Majority wins. So that is your max voting. The second one is averaging. Averaging meaning, so we will take the average of the given methods, right? Average of all the values. Here also multiple predictions are made for each data point in averaging. We take average of the predictions from all the methods and use it for the final prediction. So same here, colleague 5, 4, 5, 4, 4. So then if you see 5 plus 4 plus 5 plus 4 plus 4 divided by 5, it is a 4.5. So my final rating is going to be 4.4. In previous case, it is a 4. In this case, it is your 4.4. Then the next case, weighted average. Weighted average meaning there will be a weight for each model, right? So then based on the weight, this is also we used to call extension of averaging method. All the models are assigned with the different weights, defining the importance of each model. So these weights defines your importance of each model and it will give you the weight. Then weighted average, so weight into rating, summation of weight into rating. Obviously you will get some rate value. See here, 5 into 0.23 plus 4 into 0.23, 5 into 0.018, 4 into 0.18, 4 into 0.18, you will get 4.44. So 41. So that is what your weighted average. So this is how your ensemble learning works. These are the three techniques. One is basic techniques is one is max vote, then averaging, the third one is weighted average. So this is how your types of ensemble learning. So you can see ensemble techniques. Then third one is advanced ensemble techniques. Advanced ensemble technique. There are 4 advanced techniques. Just you understand the difference so that you can easily understand. Advanced ensemble technique. First technique is stacking. Stacking. Stacking is generally what we will do. This is also a technique. It is used. It uses the prediction from the multiple models to build a new model. So at the end, we are going to build the ML model, right? So what we will do, how will you build the model? With the purpose of building model is to take the predictions, make the predictions. So this model is used for the making predictions on the test data set. So you can see simple stacked, because this is look like a stack, so that is what we are saying, stacking. So now we have two types of stack. One is a training set stack and test set stack. Training set, before learning we will use, after learning we will say this is a test set. So first data is divided into training set and test date. The training set is further divided into 10 smaller parts. So first the data is divided into training set and test set. Then first half is your what do you call, further the first training set is divided into 10 small subsets. Then you have a test set. This is for learning. We are going to start learning. So before learning, training set. After learning, it is a test set. Now second one, here, this model is fitted on 9 parts and predictions are made on the 10th part, right? For example, see, this is a decision tree example, because we are using all this ensemble technique for classification problem. Here decision tree is fitted on 9 parts. First 9 parts I have just kept the decision tree. The 10th part is mainly for making the decisions about these 9 parts. So 9 parts are my decision tree. The 10th part is going to be my prediction on the decision tree. The same process is repeated for each part of the training set, same thing. Now using this fitted model as a whole training set, predictions are made on the test data. Now so about this we have done this. So the complete whole training set, so when you consider, when you use this model fitted on the whole training set, predictions are made on this test data. So we are taking each training sample and I am adding into the 10th row. Second training sample, again I am adding in the 10th row. But as a whole, the main decision is happening at the test set with the training DT, right? So here step 2 and 3 are repeated for any other base one. This is we are doing for the decision tree. Suppose if you want to apply the same technique for KNN, then the another row is created KNN. So here you can apply KNN method and find out. You can take the first training set and divide it into 9. Again the 10th row become your decision place. Then you go with the take second sample, third sample, fourth sample. So that is how these DT and KNN works here. So these are all prediction set, train prediction test and test prediction set, right? So this is what stacking is all about. Then here you can see the after the division, the predictions from the training set are used as a features to build the new model. This model is used to make final prediction on the test prediction test. So this is what the predicted set. So with this predicted test, this predictions used for main decisions. So the second one is a blending. Blending here, what we will do generally. First data is divided into training set and test set, same. But here what we are doing, it is also similar to stacking, but here we are using one extra column called validation column, right? So this validation is used to make the predictions, right? So you can see this example, step 1, the main data is divided into training set and test set. After that, this training set is divided into two halves. One is a training set, another one is the validation set, right? Main training set and validation set. Then here, whereas in previous cases, here this training set is divided into 10 columns, right? Here we are divided into only 2. So these base models are fitted on the training set and predictions are made on the validation set. I hope you understand. So the base models are predicted on this training set. In validation set, we will keep the predictions. So this is how this blending mode. So that is what we used to call a blended mode. Now students have a blended mode options, meaning both online and offline. So when you say this training set is your classes, when you say class, in class set you have blended mode option. One is online class, another one is physical class. So that is what here training set and validation set. A same concept is divided into two halves, right? So this is your online class. Assume this is online. So when sorry, not online, this is your class concept. So classes, but this divided into two. So online and offline, right? Offline. So that is what we used to call blended mode. Blended mode meaning the same scenario is running in two different platforms. So here the base models are fitted on training set. Another one is the predictions are happening on the validation set. So this validation set and its predictions are used as features to build the new model, and this model is used to make the final prediction as test features. That is your blended. I hope you can understand the difference between both stacking and blending. Third one is a bagging. Bagging is simply a combining predictions, right? So the idea behind bagging is combining the results of multiple models. You can collect the feedback from anyone, anything, but finally used to take the decisions. All these ideas were grouped together, common predictions, right? If you create all the models on the same set of the data and combining it, will it be useful? There is a high chance of these models will give the same result since they are getting the same input. So how can you solve this problem? That is what where your bootstrapping works. So bootstrapping meaning some subsets of observations are created from the original dataset with the replacement. Bagging or bootstrapping aggregation uses these subsets bags to get a fair idea about the distribution. The size of the subsets are created for bagging may be the less than the original set. Now you can see the original set, original data set. This original data set is here. Now it has subsets D1, D2, D3, D4, D5. Now these D1, D2, D3 have its individual models, right? So that is what this technique uses subsets. See, these are the original data. These are the subsets. We used to call bags, bag 1, bag 2, bag 3. So these bag 1, bag 2, bag 3 are applied to individual models, model 1, model 2, model 3, model 4. Then this individual models has some results here. So now these results are combined in order to make the prediction. So combined prediction. So the steps are multiple subsets are created from the original data set, selecting the observations with replacement. The base model, this is we call weak model, is created on these subsets. Then the models run in parallel are independent of each other. So nothing is dependent here. This is independent of each other. The final predictions are determined by combining the predictions from all the models. So this is what the bagging meaning everyone will come with their own idea, finally combining it, right? That is what this is bagging. The last technique. Suppose assume if the data point is incorrectly predicted by the first model and then the next, probably all the model will combining the predictions provides better results. My meaning this question. Suppose here in this bagging type, one subset uh, wrongly predicted the output. But when you combine here, that error it will affect the main prediction also. So in such cases, what you will do? That is what we used to call the method we have boosting. So the boosting, the main purpose of boosting in order to avoid the errors in the individual subsets in the bagging system. So now this boosting is a sequential process where each subsequent models attempt to correct these errors of previous model. These succeeding models are dependent on the previous models. Let's see now how this boosting working. There are different, you can see positive, negative hypothesis or test cases, right? Now a subset is created from the original data set. So now we are creating the subset. So initially all the data points are given with the equal weights. These are all you call blue plus minus. These are all our data points or hypothesis or data test set, whatever it may be. Now the base model is created with on this subset. This model is used to make the prediction as the whole data set. So now we'll see how to make the predictions. Now errors are calculated using actual values and predicted values. The observations which are incorrectly predicted are given higher weights. Here the three misclassified blue plus points will be the given higher rates. This see here the blue plus, the bigger one is called your errors, incorrectly predicted hypothesis. So this is given higher weights, right? Another model is created and predictions are made on the data set. This model tries to correct the errors from the previous models. So here there are the multiple models are created, each correcting the errors of the previous models. This is the first template. Here this three big plus given higher weights, so that will be in here. Now what we need to do, we need to segregate these errors. We need to avoid or we need to classify these errors. So this is we used to call what do you call weaker learners. So you need to avoid it. So again I am dividing into different subsets. So now these three symbols were in this other test set. The other symbols, the equal weights are in the down. So now these big plus symbols are moved here. The final model is weighted means of the all the models. So this will be the next. So then remaining all other test cases are the another column. So right. So assume this is a training set and test set. So this is how Boostum algorithm combines a number of weak learners to form the strong learners. So what we will do, we will give the higher weights to the incorrectly predicted observations. So this is what very important here. So this is what higher important here. So then the such higher weights are grouped separately. That is what we did. So these three pluses are grouped separately. So remainings are your mainly classified ones. So this is how the booster algorithm. The individual models would not perform well on the entire data set, but they work well for some parts of the data set. Thus each model actually boosts the performance of the ensemble technique. There are some more bagging and boosting algorithms are there. I think you know the meta estimator and random forest. So there are main two ensemble algorithm. One is a bagging, another one is a random forest. That is your ensemble learning algorithm. Then when you say boosting algorithms, there are different boosting algorithms, ADA boost and GBM, XGBM and light GBM and CAT boost. So I think you might have few people who have worked on ADA boost, right? So these are the boosting algorithms in machine learning. These two are your main bagging algorithms, right? So this is how your uh, uh, what do you call your ensemble learning techniques all about. Okay. So next class we will discuss the your random forest, and also before seeing that we will see how the ensemble works. Okay. So time 11:50. Okay, exactly. Okay, thank you all. So you can leave.